Good afternoon, everyone. Thank you to CII for having me. The theme of advanced manufacturing and supply chain is extremely relevant as global government and industry are committed to implementing changes in the light of climate change and scarcity of certain naturally occurring materials. I'll be speaking today mostly in the context of clean mobility, specifically electric vehicles, and the implications of the ambitious goals of adoption many stakeholders have set out for themselves. But I'm sure many of you can draw parallels to your own industry as well. Um, so I just want to share this slide just to give you a sense of the different touch points of the EV ecosystem. From our perspective, there's manufacturing infrastructure, be it charging, battery swapping, or the electrical grid itself, policymakers, research and development, and finally the investment community, sources of capital. From Basileo's perspective, these are the stakeholders we work with the most. But there is, of course, one more very important stakeholder, which is the consumer, which is worth mentioning as well. Um, I think it's important to understand that the automobile manufacturing industry has had over 100 years to evolve, and during which time ICE, internal combustion, has been the prominent propulsion technology. EVs, of course, are fundamentally different in a few different ways. For example, electric motors are much more efficient than ICE engines. There are fewer moving parts. The chassis in an EV don't need to withstand, or they don't need to be engineered to withstand the vibrations from engine. These differences present opportunities to introduce new innovative manufacturing processes and business models. They also present certain challenges pertaining to supply chain, indigenization, and ensuring quality. Um, Manufacturing pertaining to the EV ecosystem, much like the traditional automobile industry, includes vehicle assemblies, component manufacturing. In the context of EVs, they also include infrastructure-related components, such as your chargers and the battery swapping infrastructure. EVs also happen to come in different flavors, be it battery electric, hybrid electric, hydrogen fuel cell. Each of these propulsion technologies have their own suitable use cases and also their own nuances when it comes to technology and manufacturing. As a manufacturing process, a few things to note. While EVs have less parts, there are additional complexities in manufacturing. Parts can be sensitive to electrostatic discharge during assemblies. Operators need to be grounded. High requirement of precision, for example, ensuring precise torque settings, appropriate application of sealant in the right quantities and in the right location is vital. Ignoring this can lead to leakages and water ingress. Increased dependencies on VCUs, that will completely change the electrical architecture of a vehicle. Obviously, automation can help with this regard, with regard to quality control concerns. And also, I think there's an opportunity for modular manufacturing and distributed manufacturing instead of a centralized manufacturing model, uh, which presents itself as an opportunity since there's a less intensive parts list. In the concept of quality around the discussion of assembly versus manufacturing in-house. So I think companies that take the CKD route, complete knockdown route, come at the cost of concurrent engineering setup. So manufacturing is treated largely in isolation to R&D. The result is struggles with, or the result can lead to struggles with quality and consistency. And of course, I think it needs to be a good balance between automation and human involvement to ensure quality. I think we skipped one. Okay. I think again with regard to EV components, given the various pressures to transition to clean mobility solutions in a record pace, EV component manufacturers also feel the same pressures. Likewise, there's also a push for localization of battery cells, semiconductors, and motors. In the journey of indigenization, there's also a need to seek out and secure alternative raw materials which are available in abundant quantities. And of course, when we're talking about raw materials, this naturally relates to battery cells. not just in terms of availability of the natural resources, but also the suitability of the widely available cell chemistries to Indian conditions. My opinion is that it'll never be a one-size-fits-all solution, but I think it is wise as we are ramping up cell production in India to design facilities which are chemistry agnostic. This would give us a great degree of flexibility when responding to supply chain constraints. Next slide. I think the opportunity for India to emerge as a leader in clean mobility is clear. We have one of the largest automobile markets in the world, which comprises 70% of two and three wheelers. Many of the products will naturally translate to other developing economies as well. Indigenization is already underway when it comes to cell chemistries and other components. And to conclude, I think collaboration between different stakeholders, especially when it comes to deliberating which technologies to invest in for long-term sustainable adoption is key, either when it comes to cell chemistry, motor technologies, or chargers. This discussion could also evolve into developing common parts, which would potentially alleviate some of the supply chain issues and also vastly benefit the consumer. Thank you.